Okay guys, so I'm going to take this opportunity to quickly go through, maybe in 2 videos, hopefully no more than that, and go through these problems. So I'm going to explain them pretty quickly. If you have any issues, please come in and get help from me. I'm available before and after school each day before your midterm. Okay, so for number 1, what you need to do is cross multiplication. So you're going to be taking 15, multiplying it by x, and 70 multiplying it by 21. And what you get is 15x equals 1470. Okay, then to solve for x, you need to divide both sides by 15 and you get 98. Okay. For this one, h over 3 plus 4 equals 9. You need to subtract 4 from both sides. You get h over 3 equals 5. Now, since 3 is in the denominator, you need to multiply both sides by 3 and you get h equals 15. The following in your calculator, guys, just do it straight in your calculator. 55 times 23 divided by 66 times 21. This should all be in your calculator. Okay? And the reason why I want you to do this, make sure that you're dividing by 66 times 21. And it's in parentheses, or you take 55 times 23, divide by 66 equals, then divide by 21. Because if you write this out and do 55 times 23 divided by 66 times 21, you're not going to get the answer I got. So make sure you're doing the right math. Don't just put 66 times 21, put this answer, and then divide. That's not the purpose of this question. Okay? And notice 2 sig figs, 2, 2, and 2. So my answer I put was 2. 4, 15% of my students love snakes. If 25 students love snakes, how many students do I teach? This is a pretty simple question. I take 15% of my total students. That will equal the number of students that love snakes. So 0.15, because I need to make it into a decimal. So I move my decimal place over 2 places. Of all my students, I don't know how many students I have total, so that's x equals 25, because 25 students love snakes. Now I need to divide both sides by 0.15, and I get 166.7 students. Now, if we're doing sig figs, I agree. It should be 170 students or 167 students. Guys, on the midterm, it's going to be multiple choice, and it'll be obvious what it's going to be. Okay, so I would say 170, 167 is fine. I wouldn't put both answers. It would be really obvious what it's going to be for you guys. All right, number 5, 10% of the PHS teachers teach summer school. There are 56 teachers. How many will teach summer school? So 10% of all of the teachers, which is 56, teach summer school. So 0.10, because I moved the decimal place over 2 places, times 56 equals, and that's 5.6 teachers. Okay, make sure to use units, guys. All right, write the following in scientific or standard notation. 7.5 times 10 to the 6th. I need to move my decimal place over 6 places to the right to make it a bigger number, and you get this answer. For this, I need to make my number to be in scientific notation. It has to be between 1 and 10. So I need to move this decimal place over 1, 2, 3 places. So it's 6.5 times 10. Since I made a smaller number bigger, I need a negative third. This one, it's negative fifth, so I'm going to move my decimal place to the left 5 places. 1, 2, 3, 4, 5, and that's what I get. For this one, I need to make it between 1 and 10, so I'm going to move my decimal place over 1, 2, 3 places. 5.2 times 10 to the third, because I took a big number and made it smaller. For this one, it's a negative 1, so I'm going to move my decimal place to the left, but only 1 place, so it's 0.21. This one, I need to make it between 1 and 10, so I'm going to move my decimal place over once, making a large number smaller, so it's 2.5 times 10 to the first. This one, times 10 to the 9th, I need to move my decimal place over to the right 9 times. That's the answer. I get 8 zeros. Round the following, so they have 3 sig figs. So my 8, my 9, and this digit have to be significant. Since the digit after my 1 is a 5, I need to round it up to a 2. And don't forget the last 2 digits, guys. You need to include them. You can't just write 892, so I'm going to write 2 zeros, and I'm done. For this one, 0.00567, that's 3 sig figs. The 4 is less than 5, therefore I don't need to round up. I leave it as a 7. For this one, 5.63, okay, the number right after the 3 is a 4. It's less than 5, so I don't need to round the 3 up. I keep it as 5.63. For this one, 8.5, and I need this last digit to be significant. If you look, the 9 is right behind it, which is greater than 5, so this needs to be rounded to a 1, so 851, and then 2 zeros behind it. Okay. For this one, you just do the simple math, And what you should notice, guys, is since I'm multiplying and dividing and that's all I'm doing, I need to use the fewest number of significant figures. This says 1 sig fig, this is 2, this is 1, this is 2, so my final answer needs 1. For this one, I'm doing simple adding, so I need to use my fewest number of decimal places. This is 1 decimal place, this says 2, this says 2, so my final answer needs 1. For this, guys, what I'm doing is I'm adding first, and then my final step is dividing. So what I want to do is find out 5.0 plus 10.5 is going to be, I'm not sure exactly what I did here, 15.5. Okay, so that's still 1 decimal place. I'm fine. 8.3 plus 6 is 14.3. But notice this has no decimal places. This has 1. So it should just be 14. So 15.5, not 15.6, sorry, 15.5 divided by 14, that has, since I'm dividing now, I do significant figures. So 15.5 has 3 sig figs, 14 has 2, so my final answer needs 2, so it's 1.1. Same thing here. I'm adding first. Notice that this has 1 decimal place, so this answer is going to have 1 decimal place. Right, so I believe it's 65.3, correct me if I'm wrong, but 65.3 divided by 9.1, 65.3 has, now I'm dividing, okay, it has 3 sig figs, this has 2, so my final answer needs 2, so it's 7.0. All right, for the following conversions, make sure to show all 4 steps. Guys, for some of these, I didn't use all 4 steps. I'm sorry. I was really trying to work hard in order to get this completed to have a video for you. So make sure you have all 4 steps because you need to show it on your test. So I did it for a couple of them. For this one, I'm given 56.7 megameters, and I want asked to find meters. So step 2, I'm going to go from megameters to meters. Okay, I know that my megameter is a bigger unit, so there's 1 megameter, and in 1 megameter, there are 10 to the 6 meters. My next step is just to actually solve it. So 56.7 megameters, crisscross swoosh. I put my unit megameter on bottom and meters up top. And I just put this relationship in. There's a 1, there's a 10 to the 6th. Now I take 56.7 and I multiply by 10 to the 6th, because if it's in the numerator, you multiply. If it's in the denominator, you divide. And what I get is 5.67 times 10 to the 7th meters. Okay, notice I have 3 sig figs here, I have 3 sig figs here, and I have my units, and I'm good to go. Here I did the exact same thing, but notice I'm in nanometers. I want to find decameters, so I need to first go from nanometers to meters, which is my base unit, then to decameters. So here what I show you is the relationship between nanometers and meters, and the relationship between meters and decameters. So they're 10 to the 9th nanometers in 1 meter, and they're 10 meters in 1 decameter. If you guys aren't sure about that relationship, double check it yourself. This is correct. Just think about what unit's larger. That's the one that gets the 1. The other one gets the relationship. Make sure not to have a negative in your exponent. So now I'm going to write it out. 567 nanometers, crisscross swoosh. Nanometers on bottom to cross them out. Meters up top. Crisscross swoosh again, get rid of meters. Get into decameters. Now I put on those relationships and I take 567, divide it by 10 to the 9th because it's in the denominator, and divide by 10 again. And this is what I get for my answer. 3 sig figs, 3 sig figs. All right. Here, notice I'm raising units to a power. The only thing that you have to do for this, guys, it's really easy. The only thing you have to do, take the relationship that you have and raise it to that power. So for example, 500 meters squared, crisscross swoosh, I'm converting it to millimeters squared. So I put 1 meter squared on bottom because meters are larger than millimeters. They're 10 to the 3rd millimeters in 1 meter. So 10 to the 3rd, but I have to square the 10 to the 3rd. That's the only thing that changes when you're raising a unit to a power. So then when you multiply, because it's 500 times 10 to the 6th, right, because 3 times 2 is 10 to the 6th, you get 5 times 10 to the 8th. Notice 1 sig fig, 1 sig fig. Don't write 5.0. That would make that 2 sig figs. For this one, same thing. 1,340 centimeters cubed, crisscross swoosh. I put centimeters cubed on bottom, meters cubed up top. My meter is larger, so I put a 1 there. There are 100 centimeters in a meter, but notice I have to take the 10 to the 2nd, or 100, and I have to cube it because that's what my unit is raised to. So then I take 1,340, divide it by 100 cubed. Okay? For these problems, guys, I did not do my 4 steps. You need to do your 4 steps. Sorry, life is hard. Okay, number 10. This is a density problem. I will include a formula for density on your test because that was requested. All right, in this problem, I'm given 600 grams. Grams are your unit for mass. I'm also given my volume, 16 milliliters. I'm asked to find my density. So I'm going from mass and volume, and I'm finding density. That's my formula. So I just plug and chug 600 grams over 16 mils, and I get 38 grams over mils. Let's check my sig figs. 600 has 3 sig figs. 16 has 2 sig figs, so it should be 38 because that's 2 sig figs. Notice my units, grams divided by mils. Because I included units here, it makes finding units for density super easy. Okay. Number 11. What is the volume of a gas that has a mass? So mass is 55.6, that's my given, and a density of 3.5 grams over liters, that's my density. So I'm trying to find my volume. So mass, I know density, trying to find volume. So for my step, density equals mass over volume. Now, what you can do to find your formula for volume, take density times your volume, set that equal to your mass. Then divide both sides by your density, and this is the formula you get. Or you can just plug in your numbers right up here. It's totally your choice. But what you should get in the end, if you're going to use this formula, you do your mass, 55.6 grams, divided by your density, which is 3.5 grams over liters. Notice, I'm just dividing, so this is 3 sig figs, this is 2 sig figs, so my final answer should have 16 liters. Okay. If you plug in numbers, right, you'll plug in your mass here, your density here. Be careful with the math, please. This is what you should be doing in the end. Okay. Comment if you have any questions, guys. Okay. Number 12, identify the following as a pure substance or mixture. If it's a pure substance, classify it as compound or element, mixture, homogeneous or heterogeneous. Okay. Sodium metal. Sodium metal is, I didn't write this, sorry. Sodium metal is a pure substance. It's an element. If you can find it on the periodic table all by itself, it is an element. Sodium is a group 1 metal. T is a mixture. It's a number of different compounds, but hopefully it's homogeneous. Hopefully you don't have bits of tea, leaves, and everything like that in your tea. Oxygen gas, O2. That is a pure substance, and it is an element. It's actually a diatomic element, which we talked about earlier. But it's an element. It can be found on the periodic table. Fruit salad, that is definitely a mixture, and it's heterogeneous because you're going to get a different thing every time you take a bite. Apple juice. Apple juice, again, is a mixture, a bunch of different compounds and elements, but it's homogeneous because you're going to get the same thing each time you take a sip. Vinegar is a pure substance. There's the formula right there for you, but as you notice, you're not getting just one thing from the periodic table. These are all bound together, so therefore it's a compound. Air is a mixture. You've got nitrogen, oxygen, helium, chlorine. You got all of these gases in the air. Therefore, it is a mixture. However, it's homogeneous because you get the same thing every time you breathe in. Hopefully, right? If you don't, suddenly you won't get any oxygen and you'll drop dead. All right. Table salt, NaCl, that is a pure substance. However, since they're 2 different elements, it's a compound. Gold is a pure substance. You can find it on the periodic table. Therefore, it is an element. Cheerios with milk, that's a mixture, and it's heterogeneous because each time you might get a couple of Cheerios, you might get a bunch of Cheerios. Coffee, again, mixture, water and coffee. Coffee is a mixture even without the water, but it's homogeneous because hopefully you're going to get the same thing each time you take a sip, or else that's really gross coffee. Identify the following as a chemical or physical property. Boiling point, this is, remember, physical property, you can observe it without changing the identity of the compound or element. Chemical, in order to observe this property, you have to change it. So boiling point, I'm changing it from a liquid to a gas, but I'm not changing the identity of whatever substance I'm talking about. So it's physical. Melting, same thing. I'm just taking it from a solid to a liquid, but it's the same identity, so it's physical. Ability to rust, you're actually changing the identity of iron to iron oxide, so it's chemical. Elasticity, if you stretch a rubber band, you're not changing its identity, so it's physical. Reactivity with vinegar, if you react calcium carbonate with vinegar, you're definitely changing its identity, you're disintegrating it. Brittleness, right, how easy it is to break it, that's physical. Breaking, you're not actually changing its identity. And ductility, right, being able to stretch it into wires. Okay, if something's ductile, again, you're not changing the identity, therefore it's physical. Okay, guys, go to the next video to see the rest of my explanations.